Next, student, since the Cm is fixed in the kinetic energy is all rotational and constant, and therefore rotational kinetic energy is equal to 1 by 2 omega L बराबर है constant. We know that L is constant. Rotational kinetic energy will also be constant. Rotational kinetic energy जो है वो constant रहेगी if the tip of the angular velocity vector omega rotates in such a way that its projection on the angular momentum vector L is constant. जो टिप है एंगुलर वेलोसिटी वेक्टर की वो रोटेट करती है इस तरह अगर प्रोजेक्शन एंगल एंगुलर मोमेंटम ये वो कांस्टेंट है तो figure 9.3 the angle phi L between omega and L is given by cos phi L is equal to omega vector dot L divided by omega L is equal to 2 rotational kinetic energy omega L is equal to constant. Next है students हमारे पास angle phi L remains constant and is the semi-vertical angle of the space cone. This cone results from the precession of omega about the constant angular momentum. As viewed from the space coordinate system. On the other hand, when viewed from the body coordinate system, omega precesses around the OZ axis. This situation is shown in figure 9.4 and may be described as one cone rolling on another. The body cone is rolling without slipping around the space. जो body की जो cone है वो without slip की roll करती है and the line of contact is the direction of angular velocity omega. Line of contact क्या है वो angular velocity omega की जो है direction which precesses around the OZ naught axis when viewed from the space coordinate system. The angular frequency of precession of omega about the OZ naught axis omega is equal to I3 minus I1 divided by I1 omega 3 equal to gamma omega 3. Similarly, the angular frequency of precession of omega about the OZ naught axis is given by omega L is equal to gamma omega 3 sine phi b divided by sine phi L. Depending on the values of ix and I3 of ig, the body cone may roll outside or inside the space. Body cone जो है वो space के inside और outside में roll करती है as shown in इसको 9.4 के अंदर शो किया गया है. Next है applications to the rotating earth. Application to the rotating earth. The above theory of the symmetrical top can be applied to the rotation of earth. The earth is known to be slightly flattened near the poles, because of which it can be regarded as an oblate spheroid. This gives I1 is equal to I2 is equal to I3 and I3 greater है I1. Therefore, the angular frequency is equal to I3 minus I1 by I1. Omega 3 is much smaller than omega 3. एंगुलर फ्रीक्वेंसी जो है वो much smaller है omega 3 से, such that sigma omega angular frequency approximately equal to omega by 300, since the period of earth rotation is 1 by omega is equal to 1. One day and omega 3 approximately equal to omega 3, we get 1 by angular frequency is equal to 300 days. P बराबर है 2 pi by sigma by angular frequency is equal to 2 pi I1 divided by omega 3 into I3 minus I1 is equal to 1 day divided by 0.00327 is equal to 305 days. The measured value is 440 days. The difference can be explained by noting difference can be explained by noting difference can be explained by noting that the Earth is not a perfect sphere. Neither is it strictly a rigid body. ना तो perfect sphere है Earth और ना ही strictly rigid body है. General motion of a rigid body. Next है हमारे पास in the general motion of a body, the Fc is the total external force on the rigid body, and Gcext total torque, external torque about its mass center. Then the equations of motion are MACFCEXT and LC is equal to GC, where AC is the acceleration of the CM and LC is the total angular momentum about it. Now we resolve the vectors AC, capital F, capital GC and L along the unit vector IJK taken along the principal axis at the mass center. The triad of vectors IJK may be referred to as a principal triad. It will be assumed to be permanently in principal triad. इसको permanently जो है principal triad consider किया जाता है. Let angular frequency is let omega be its angular velocity. If the triad is fixed in the body, then omega is equal to omega naught, the angular velocity of the body. Now using the relation df over theta बराबर है df theta plus omega cross f, which relates the rates of change of vector in a fixed frame and rotating frame. We have AF is equal to d over theta to f is equal to dv over dt plus sigma cross omega cross v. Vf is equal to Vr is equal to V. Af is equal to dv over d plus omega cross v, where v is equal to vi, v1I plus v2j plus v3k is the velocity of the mass center. Substituting for Af is equal to Ac from 9.513 into 9.5.1, we obtain capital M into dv over dt plus omega cross v is equal to capital F, which is equivalent to M into v1 dot plus omega v3 minus omega 3 v2 is equal to F1. M into v2 dot plus omega 3 v1 minus omega 1 v3 is equal to F2. M into v3 dot plus omega 1 v2 minus omega 2 v1. dl over dt f is equal to dl over dt plus sigma cross L, and the relation L is equal to I1 omega 1 I1 plus I2 omega 2k plus I3 omega 3k will obtain the equation I1 omega 1 dot I plus I2 omega 2 dot j plus I3 omega 3 dot k plus sigma to omega to L3 minus omega 3 L2I plus omega 2 L1 minus omega 1 L3j plus omega 1 L2 minus omega 2 L1 k बराबर g.